Okay. Let's take a look. I got 1 and 2. What can you say about 1 and 2? Are they congruent? They are corresponding, aren't they?
We don't know if they're congruent because we don't know this one.
Very good. Good. That's what I'm looking for, okay? You don't know they're congruent to each other, do you? Because you don't know that what? That they're parallel to each other. Now, if I told you, listen to me, if I told you that they were parallel to each other, then what could you say about 1 and 2? Then you could say they're congruent. But I don't know they're parallel. What if I did this? What if I said, you still don't know they're parallel lines, okay? But what if I said that angle 1 equals angle 2? Absolutely, that's right. Did you hear what he said? Chris said that if angle 1 is equal to angle 2, then you could say that the lines are going to be parallel to each other. And that's absolutely true. So let's think about what we said earlier. This was before. Remember that first, we call it a postulate? Remember that first postulate? Forget the numbers, like I think it was 3-1 or something, right? But again, I told you not to remember the numbers. But the postulate said this. I'm going to really go shorthand. If it said, if you have parallel lines, then what do you think was true? Then the corresponding angles were what? Congruent or equal, okay? That means if the lines were parallel to each other, then the corresponding angles were equal. What do you think this postulate says? If the what?
If the lines are parallel.
No, this said if the lines are parallel. Well, if the corresponding angles are congruent, then, that's right, then the lines are parallel to each other, okay? This is the original statement that was our first postulate, wasn't it? That was our original statement. This right here, look what I changed. I changed the if and the then, didn't I? It said if the lines are parallel, then the corresponding angles are equal. This says if the corresponding angles are equal, then guess what? The lines are parallel. Do you see that? And when you learn this stuff, it's logic and things like that with if-then statements. But we use this. If P, then Q. The P represents the if part. The Q represents the then part. Okay? Technically, they call this the hypothesis and the conclusion. I'm not going to get into that right now. But if P, then Q. If the lines are parallel, then the corresponding angles are congruent. What about this? If the corresponding angle is congruent, then what? Then the lines are parallel. What did we do, the P and the Q? We switched them, right? So this would say if what? If Q, then P. Do you see that? If this is our statement, we give this a name as well. We call this the converse.
Isn't there a stat law that's, what are they called? Like, or associative property?
Yeah, there are that stuff, but I don't think that has to do with this, though. All right? So anyway, this is called the converse of the statement. Not every single converse of every if-then statement is true. All right, you follow me on this? We're not going to get deep into this, but not every converse is true. In this particular case, though, it is true. That the statement and the converse are absolutely true. You okay with that? All right. So that's what it says. So we also had some other things. If the lines were parallel, then the corresponding angles are equal. What else was true? Then the what? Alternate interior angles were equal. What else was true? Alternate what? Exterior angles were equal. Then we had another one. What was that? That the consecutive, I'll just shorthand it, the consecutive interior angles were what? Supplementary, right? That was all contingent on the fact that what? The lines were, no, the lines were parallel to each other. Over here, what do you think we're going to do? We're going to say, if what? If the corresponding angles are equal, then the lines are parallel. What else can you say? If the alternate interior angles are equal, then guess what? Then the lines are parallel. If the alternate exterior angles are equal, then guess what? The lines are parallel. What else? If the consecutive interior angles are what? Supplementary, then the lines are parallel. Do you see the difference? It's very, very similar, isn't it? It's got a very strong relationship to each other, but it's a little bit different. It's not saying that we start off with parallel lines. It just says, okay, we start off with any two lines cut by a transversal. if I was able to show you that this angle and this angle are equal, they're corresponding angles. If they're equal to each other, then guess what must be true about these two lines? They got to be what? They got to be parallel. You follow me? What if I threw another? Sorry for all the mess. I tell you what, let's do this. Let's copy and paste this so it's the same angle. What if I did this? And why did I pick 4? Let's pick 3. It's next, isn't it? What if I said that 1 is equal to 3? Now watch. Let's call this line L and line M. We'll call this P and Q. Is that all right? You with me? So watch. If I told you that angle 1 was equal to angle 3, what could you tell me about some lines here? If 1 was equal to 3, what do you think would be true, Rachel?
That P and Q are parallel.
That's exactly right. Because look, what's the relationship between 1 and 3? Well, these would be two lines. This would be your transversal right here, wouldn't it? Okay, so these are corresponding angles, aren't they? Okay, they're corresponding angles. Which lines must be parallel then? L and M? No. P and Q. That's right, because M has nothing to do with these two angles up here, does it? You see it? So that's what they're going to do. They're going to give you a whole bunch of lines all crossing each other. You're going to have to take a look to see the relationships between those angles. Okay, if those angles are equal, you got to see which lines are going to be parallel. So if this was true, they're going to say if angle 1 is equal to angle 3, then guess what? Line P must be what? Parallel to line Q. You get it? That's the kind of stuff that they're going to do. And sometimes it gets a little bit tricky because there's a lot of lines flying around all over the place, a lot of angles all over the place. You got to figure out if those two angles are equal, which two lines are parallel. Now, if all I said was angle 1 and 3 are equal, could you say that L and M were parallel? No, not because 1 and 3, but because 1 and 2, you could say that L and M were parallel. Do you see the difference? All right. That's basically it right there. You think you can handle that? Okay. So, let me see what your assignment is. It's section 3.5. And where am I? Well, let's call it 3.5a because we're gonna do a second part of it tomorrow. So yeah, we're gonna do 3.5a, and it's page 209.
That's our whole lesson.
Yep, that's your lesson.
In under 10 minutes.
See, told you I'd do it quick. And we're gonna go 8 to 21. All right, there it is, right there.
What about I?
How about all?
Okay, that's fine.
How about I double it if you ask
Okay,
me
actually,
again?
I would rather you double it.
Okay.
Ben, stop. Some of us
You're not
are
making
actually
many
busy
friends
tonight.
saying that.
Some of us are actually busy tonight with not much homework. So.
Oh, like not you.
All right, there it is. Okay, call it A, 3.5a, 8 to 21. You're gonna do them
On
all.
YouTube, you
Alright.
heard on Thursday when we watched the early dismissal. It heard the announcement was on that, and you're like, "See you, ladies."
Oh, yeah. All right, very good. All right, anybody have anything else to say? No.
I like
Bye.
that.
Say bye.
I like cheese.